is
Yeah.
get out of class till 4.
So we don't.
Or it's not snowing, so they're outside enjoying the sun, even though it's cold.
Instead of weather watch, why would you watch the weather outside and then look at it on a screen?
Why would you want to look out the window?
I would do it 1 year. Yeah, I would probably.
Okay. Ready to go?
Yep.
Okay, welcome to our weather discussion. It's for the week. It's been a really interesting couple of weeks. It's an every Thursday event now. Well, the discussion's Friday, of course, but we're getting snow every Thursday. And I don't even know if that won't be true this week. Patrick's going to tell us, but it's possible, amazingly. So for 3 weeks in a row. We're looking at the last week infrared. We're currently on about Sunday, and you can see one after another of these just gorgeous extratropical cyclones, upper-level waves. That was the one that gave us snow on the prior Thursday. I think this is this week, right? Yep. That's this event. And this is yet another disturbance that's kind of dying out. But we saw, Coach and I have a collaborator who lives in Tucson, but she's at City College, New York. And the same event that gave us snow on Thursday gave Tucson a dusting of snow on Wednesday. And that's the first snow they've had all year. So I want to tell you a little bit about why that happened as we go through the current weather discussion. And then Patrick Beatty's going to do the forecast. So that's what we're going to do today. Pete will be driving the boat. So just a beautifully stormy period, one wave after another. I think, Pete, so we've seen this. Let's take a look at the the visible imagery that shows where the snow is.
Oh, the visible or the...
Well, your favorite one will work, because I think it shows up something kind of cool. So where it's green, I understand that's where the snow is, and you can see it's darker red here and here. So if you're in some of these towns in this blue strip, even despite all that beautiful cyclonic wrap-up that's been going on across the country, and across the middle section of the country in particular, you have been relatively snow-free, which, if it were me, it would drive me crazy to see all of that stuff going on to my south and to my north, and just have it miss me. So just north of Green Bay, all the way down through northern Iowa, Storm Lake is there, I think, Clear Lake, Iowa's there, and then almost to Omaha, a little bit north of Omaha, Sioux Falls. Not much snow over these last couple of periods. So that, I was just saying, that would drive me crazy. It would absolutely drive me crazy. I think Thursday of the coming week looks like a thing that might drive me crazy, because it's going to snow in the northern part of the state, perhaps. So, so some interesting things. Can we look at a regular black and white visible, though, to show this too, Pete, in non-animated, just for one image? Yeah, so you really can see it. Isn't that spectacular? There's the snow band. Looks like it stopped snowing on the northern edge of the, is that the Missouri or the Platte River? That's the Missouri, or the Platte, I think, right? So it looks like it stopped snowing there. But, and then there's the northern band from maybe last week and partly Thursday, but this is the main Thursday band that we just saw. And 3.8 inches of snow at the airport. I don't think it was much different at my house. I don't know if regionally anybody had a sense that it was greater than that in their own backyard, but so pretty good snow. Interesting forecast during the week. We were talking at some point about 7-ish inches of snow, and it sure looked like we were on target for a pretty big event. Though I have to confess, all through the week I had a little bit of doubt about the nature of how we were going to just create any sort of sizable blob, not isotropic band of vertical motion. So, and I'll show you why I had that impression with a little bit of information from our standard maps. Unfortunately, I didn't have time to present, to prepare anything more than that. So I guess in the back of my mind I had some doubts about whether or not we'd really get concentrated vertical motions of a long enough duration to give us like 7 inches of snow. But the rapid refresh model, or whatever it's called, the high resolution rapid refresh, was dropping the precipitation amounts dramatically on Wednesday afternoon. And it seemed as if they were implying a moisture starvation, which didn't happen. And so I was curious, and I don't know enough about numerical modeling to say more than that. Just was a curious, late in the game, reduction in the forecasted amount of snow. But it turned out to be more on the right track than the 7 inches, because we only got 3.8. So yesterday afternoon, though, between, I don't know, 4:30, 4:05, and 6, it was coming down like I haven't seen all winter long. And we were walking in a graveyard of all places, which was perfect. Because you can see the whole big landscape. There's only a few trees, and you know, there's something about cold stone in a great snowy landscape that really nourishes my soul. And it made me think, you know, if someday I'm actually underground in one of those places on a day like that, I'll be really, really happy. But I'll be contently sleeping there. So that will be nice. But a really beautiful event the last couple of Thursdays. Let's take a look at the national satellite right now, last 6 hours or so. Good. Yeah, so really nice. So here's our snow band on a broader scale than what we just saw. You can see it kind of nicely in the visible. Much colder air in the wake of this storm. And you know, 10 degrees I think this morning at the airport, or 10 at my house, 11 at the airport at 9 a.m. So a pretty chilly morning. Meanwhile, we'll see in a minute, temperatures on the eastern edge of this cloud mass, which is part and parcel of the same storm that just went by us. Notice an absence of a really well-developed comet head to the northwest. This thing just could not wrap up. And that was what I was worried about all week for reasons that I hope to be able to show you when we go to 500 millibar maps. That turned out to be right. But even in spite of that, we got 4 inches of snow. The temperatures are in the 50s, all the way from Portland, Maine, to the 60s or 70s on the coast of Georgia today. It's just incredibly warm for mid-February. And that will change in those locations, but not as dramatically or for a very long period of time as it did for us. And even us, we're going to warm up over the weekend. I don't want to steal your thunder, Patrick, but it's going to be considerably warmer than it was today by the time we get through Saturday and Sunday. So that's nice. But we're going to also take a look at the West Coast in just a second. But you can see widespread clearing across the central part of North America, even over Colorado and western Kansas and you know, the northwest part of New Mexico and Texas. That's all snow cover. And then you can see obliquely disturbance at about the latitude of, I don't know, between San Francisco and Los Angeles. That's a pretty decent upper disturbance with pretty chilly air back behind it, indicated by the open cellular convection. And then always, never bores me that the clouds on the eastern side are stratiform and well put together, and these are all convective. That's just the nature of these beasts. If you viewed it from space only and you had some idea about that this was a water planet and that you knew something about fluid dynamics, you'd probably be able to say, oh, that must be colder, porous stratification there over a liquid surface, and these are organized in some other way, which is kind of cool. All right, let's take a look, Pete, if we could, at the West Coast satellite image. Earlier this week, it was very interesting. There were a couple of really interesting disturbances that have since sort of died away or migrated out of the region. And so today's map looks a little bit less interesting in some ways, but not in all ways. I'll focus first on this disturbance off the California coast. So the upper level cyclonic disturbance, and I think we'll see a low geopotential height minimum here at 500 millibars, is just about west of San Francisco. And with a cloud mass coming up from the, you know, I guess modest subtropics, actually extratropics. What's really interesting to me, though, is look at this. This looks like a fairly innocuous upper disturbance to the west of Hawaii, which is at about 28 degrees, 27 degrees north latitude, maybe. And look at where this cloud mass is coming from. It's quite obviously from the very deep tropics, comes well off that map. And so I'm guessing it's really rainy and miserable over the whole state of Hawaii today, with probably not much relief in sight during the day. And very, very interesting. If Greg were here, he'd be talking about the spokification of this cloud mass as some sort of signature of inertial instability as you bring air from really low PV values up into an environment where it's very high PV and it's kind of inertially unstable. And there's ramifications for that. I'm not an expert. But what an interesting picture in the satellite. And one gets the impression that the ITCZ is kind of well lit up right in the middle part of the Pacific, and this disturbance has migrated far enough southward to drag some of that tropics. Yeah, look at that. Look at that huge area of disturbance in the ITCZ, and effective baldness at this longitude band, and again, well to the west. So very, very periodic. Who was it that talked this fall and had done this really interesting analysis of just finding the 500 millibar vertical motions? I can't remember. It was a visiting scholar. Great talk. And you can find pockmarked regions in the ITCZ by just doing something that simple. Indicate how many days at 500 millibars vertical motion exceeds this value or something like that on a daily average, and see what it looks like in a season. Really cool. But that's it. I mean, that is an excursion of the tropics into the middle latitude. Probably not without consequence. And then another one that we'll see when we go back north again, Pete. This is a disturbance that maybe the circulation center is in the Bering Sea, and this is the eastern edge of the cloud mass associated with that one. It's getting stretched out from southwest to northeast, just like our feature was over the central part of the U.S. this week. So again, not much can develop in this backside of the storm, but nonetheless, one gets the impression that the moisture feed is again from high subtropical latitudes in the western part of the Pacific, central part of the Pacific. So, you know, a couple of really big plumes advected poleward here in the Pacific Basin, the more dramatic one near Hawaii. So that's interesting. I don't know what it might mean for the way the weather will evolve across the eastern Pacific and then into North America as the days go by. Perhaps we can visit that in the forecast. Let's go to the 500 millibar map, if we could, Pete. And let's go to the movie, the Super Pete movie, ending at the current time, and then we'll go backwards. So here's the Super Pete at 7 a.m. this morning. And you can see a pretty decent upper baroclinic. Can you slide a little bit further north? Yeah, perfect. A pretty decent baroclinic zone right over the Red River in Texas and Oklahoma here. The temperature at Oklahoma City is minus 26. It's minus 12 at Del Rio. It's probably about minus 12, minus 14 or so near Dallas. So that's a pretty tight temperature gradient at 500 millibars. Nothing like what it was earlier this week, which was even more impressive. And it has a strong vortex signature as well. But look at how the upper trophiness over the Great Lakes region, and we'll trace all this stuff from where it came from in just a minute. This is a fairly sharp upper trough that has a strong baroclinic edge to it on its eastern side. But boy, the curvature part of this is really limited in terms of how it's going to contribute to the vorticity strip. Most of the vorticity strip that we'll see associated with this is going to be a function of the shear in the horizontal. 100 knots at Buffalo from the southwest, 30 up in the northern part of Michigan from the west. So that's a really strong shear line, and you can trace that all the way back to the base, where there's a little bit more substantial curvature over the Red River Valley, Arkansas, and Louisiana, parts of Texas. But this whole thing that went through us was more or less a shear line, it seems to me, even looking at this map. And the consequence of that, I think, is that it was really hard, with this big, broad upper trough to the north, really hard to develop a cloud head to the northwest side of this whole development. And that still seems to be the way it looks on the satellite. There's just nothing that really filled in on that backside because the trophiness was overwhelmed by the stretching deformation along this flow. And it was impossible to build anything back there. No ridge building downstream, which enhances the vertical motions, also enhances the longitudinal extent of the heavy snow, so that some of the places that were in the blue there and haven't gotten any snow in the 2 weeks would have gotten some if we'd been able to build a ridge downstream. Just not the right environment for that. And that's the thing I had a suspicion about as the week drove toward Thursday, is that this was going to be a linear type feature, and it was going to be kind of, the Weather Service was talking about a wave coming in the northwesterly flow over Canada and linking up with it, but they linked up in such a way that it just kind of stretched away to nothing, unfortunately. But we still did pretty well. And then here's the cutoff that we saw evidence of just off the coast of San Francisco. And the flow is stronger on its western side than on its eastern side, but even so, there was a big cloudiness coming in Southern California as a consequence of its presence. So let's go back a couple of times, Pete. So let's go back to 12Z yesterday, at which time, okay, there we are. At which time, here's one of the waves that ends up being the fairly small curvature feature that's now to the east of the lakes. That's a kind of a broad feature, but notice it has very little baroclinicity, minus 36 there, minus 31 near Lake Winnipeg, and it's minus 31, minus 31, minus 34. Broadly, the same temperature. This feature down here over the border of Kansas and Nebraska, extraordinarily sharp horizontal temperature contrast. It's about minus 30 in this region, and then it's in the minus 15 range immediately adjacent to it to the south and east. So that's a strong upper front, very strong shear. Look at the wind shift here, 90 degrees and 100 knots of difference in speed. So the shear itself is strong, and there's tendency for a cold advection in that cyclonic shear, and so the tropopause is being pushed downwards over the panhandles of Oklahoma and Texas as late as, what was that, yesterday, early in the morning yesterday. So the stage was still being set, but I had the sense this is going to be where the vortex strip is. We'll go to some maps and show that in just a minute. So it's right in where that upper front is. So only at the head of that vortex strip are you going to have any substantial PVA. But boy, that was enough to give a semicircular region of decent ascent that traversed the region. And probably, I'll tell you, if you put it on the map, it would be just about the axis of that snow band, would be where that PVA maximum was the whole time. And not really broadly assisted or strongly assisted by this feature to the north. Can we go back one more day And keep your eye now on this baroclinic zone. Oh, look at that. Minus 36 is the analysis, but actually minus 35 is the op right there. Minus 14 at San Ysidro. So that's 22 degrees at 500 millibars across that thing. That's an exceptionally strong upper front. We'll go to Alicia Bentley's, no. We'll go to tropical, because they do the cross sections, right?
Yeah.
2 PVU air was down to 900 millibars over the Sonoran Desert in this event. 900 millibars. That's unbelievable. I've never seen anything like it. I think it's at this time. So we'll just search through and try and find the right time for that. So just the two features of interest. This thing is a kind of a better, well-developed upper trough 2 days ago than it was when it came near us. And then here's the other upper trough. Again, relatively void of serious baroclinicity, although it's just because it's so cold. I mean, this thing's coming out of desperately cold air, minus 40-ish at 500 millibars. But all the baroclinicity is down with this one to the south, which I suspect has geopotential heights that are way below Climo for mid-February right here. So this is an unusual disturbance, unusual latitude for it, well developed. Had this been in April, I mean, there'd been a major severe outbreak, I'm guessing, right over the plains, because you'd have dragged the plateau air out over the elevated mixed layer, would have gone crazy. Let's go back 12 hours, Pete. I think this maybe is the last time you can really see it. That was 24. Let's go ahead one. Yeah. So here's another example of how strong that temperature contrast is. Minus 38 at Reno. That's an observation at 500 millibars. This is minus 18 near San Francisco. So that's 20 degrees across the Central Valley of California at 500 millibars. And the wind shear goes from 75 from the north to 20. So you get an incredible horizontal shear there. And that's consistent all the way along this baroclinic zone. I'd say going all the way up to about the Portland area, where it's minus 30 at near Portland, Medford, and warmer than that in the minus 20s on the eastern side. So this is a gangbusters upper front. The coldest temperature I see is minus 37 at whatever that station is.
38 right next to it.
Oh yeah, we already said Reno, that's right.
Oh, yeah.
So Reno's the coldest, yeah. Reno's the coldest. I thought it was a little colder. So a very strong upper front. And here is this little drizzle event, rain event on Wednesday that came through. If that had been cold enough, we would have had a lot of snow out of that. But this was the one that turned into our Thursday snow event. Let's go now to the 300 millibar maps. Take a look at what this same sequence looks like. This time we can start at that time, which was 0Z on the 14th or something, I think. I guess it was further than that. Maybe it was 0Z on the, this is right there, 0Z on the 15th. So at the time where we saw the strong upper front with the minus 38 at Reno, look at that sharp jet structure. We have wind speeds in the 145 or higher knot range all the way along the coast of California. And that's on the western side of this upper trough. Forecast would certainly suggest that this thing is going to dig and become a little bit more impressive of a trough. Even thinking just about the jet itself and the speed variation, it's a stubby jet streak. 161 knots is the maximum wind speed in the analysis. I don't think we actually have one that high. But so the left jet exit region is a region of ascent, and that's going to cool the air here, and so that's going to lower the thickness, lower the geopotential there. And so one imagines that the upper trough will dig. And for a while, that did look to be the case. We'll see what happens as we go forward. This is the sharp upper feature and jet streak associated with our Wednesday, Tuesday night into Wednesday rain event. So let's go ahead 12 hours. And this is what kind of happens to this thing. This jet gets all the way to the base of the trough, and it's really strongly extended, perhaps connecting with the feature that was associated with this other trough, which has now moved over to the eastern Great Lakes. So once this jet gets kind of extended like that, and we go one more time, I think the whole troughiness to the west starts to collapse a little bit, so that the whole feature starts to get stretched out. And I was worried about that when we were at Wednesday night, thinking, Tuesday night, whatever the day.
I think that's actually Wednesday night.
You need to put days on here. I don't need to put days of the week. But anyway.
Tuesday was Valentine's Day, so 0Z on the 16th would be Wednesday night.
All right, so I should have remembered the Valentine's Day. You just exposed me as a terrible husband. Which I have several people, well, one person in particular would probably agree. But here's the jet streak. And once it's rounded the base of the trough is decent looking, but it's more textbook looking. It's not ominous. And so all of the vertical motion that's likely to occur with the progression of this feature is going to be tied to aspects of the shear associated with this feature, as well as perhaps some frontogenetic activity in the lower troposphere. And that was what the Weather Service was talking about. And they were broadly right about all of those things. But one other aspect of this map before we depart it is look at, again, how backed up the flow is. There's this ridge, trough, and then finally not much of a ridge down over the east coast. But it's been like that for much of the month of February, quite wavy. I think last Friday when Isaac and Kayla were showing, that was, I think, the leading adjective you guys used was how wavy this flow is. It's all over the place. So it's been a very wavy month of February over North America. I don't know about the rest of the hemisphere, so that's kind of been interesting. And one last place, Pete, let's go to 850 millibars, and we'll only go back a couple of times. We don't have to go all the way through this whole long evolution that we've done at upper levels. And then I want to show you some cross sections if we can find them. So maybe we'll get to, yeah, right about there, 12Z on the 16th, maybe? Yeah. So here's our, this is Wednesday morning, right? Thursday morning. So this is as the storm's getting itself together to our south. It hadn't yet started snowing here. It was snowing in Janesville around this time, but not at Madison. But look at how strong the baroclinicity is, even at 850. Remember, we were talking about it being quite strong at 500 millibars. This is a deep frontal structure that goes all the way almost down to the surface in a lot of locations. And then there's a decent warm frontal structure across the southern and western lakes. It's +7 at Lincoln and -6 at Green Bay. And the winds are 90 degrees opposite each other, about 20 knots on each side. So that's strongly frontogenetical. We're on the cold side of that. So the ascent associated with that was what triggered the snow. If we can go 12 hours ahead, and you can see how much stronger that baroclinicity actually got. You don't often see this, that the measured baroclinicity intensifies, because you can have something that's frontogenetically active for many hours, and the vertical motion will kind of wash out the horizontal differential temperature advection so that it doesn't look like anything's changed. But in this case, not only was the circulation strong, but the advection was strong enough to even be stronger than the circulation washing it out, it seemed like. So we end up with a really strong warm frontal baroclinic zone and a strong cold frontal baroclinic zone. By this time, about 6 p.m., the snow was winding down, because the heaviest snow would have been right in this location, maybe still snowing in Milwaukee County probably, but not over us. But a pretty decent storm for a collection of ingredients that really were not perfectly phased to drive this thing to the limit. And had that been available, we might have really seen a sort of a record-setting event. And then I guess Patrick will tell us a little bit about what happens next with this little clipper that's coming out of the Great Slave Lake area of the Northwest Territories. That should slide to the southeast over Lake Winnipeg and develop a little, but what it does to us is a mystery to me. I've not looked forward to that. And there's the Tuesday and Wednesday rain event, so it's 1, 2, 3. It's really been active. Let's go to tropical, Pete, and see if we can't dig up an old cross-section from somewhere on the 14th or 15th or 16th, and then I'll be done. And sorry I don't have more prepared. It's just been one of those weeks. Had that been the case, it would have been really fun to do it. Let's try 12Z on the 15th. Yeah. And can we, it might be easier to see it if we go to the upper dynamics and look at 500 millibars vorticity, so right there.
We need a different region.
Yeah, maybe a different region, but it's not the right time either. We'll go earlier too. So southwest, yeah, let's try southwest. Yeah, wrong time. So let's, why is it insisting on that one? Let's go to 0Z on the 14th, and then we can go ahead. I don't think it's any forecast. And it keeps defaulting to now, so we're gonna slide back and see what it looks like. I think that's what it's doing. Okay, so step forward. That's our feature coming down in the northwesterly flow. Keep going. We'll find a good time. Keep on going. Why is this? Oh, this is only on the 13th. It's okay. That's the first event. Let's keep going. I just want to find the right time. There it comes. There it comes. Oh, yes. Yes. Keep one more. Right about there is probably going to be good. Let's take a cross-section right through there. And this, unfortunately, it's a pretty far out 30-hour forecast valid at this time. But let's look at the PV. Whoa, okay. So this is the warm side, this is the cold side. and here's the way the cross-section runs out. So here's the 2 PVU contours, the dashed line. It goes all the way down to 850 millibars in this cross-section. And the green lines are potential temperature, so an extraordinary upper front starting somewhere around, 450, 350 millibars all the way down to, it's capped at around 850 or so like that. This is just a stable layer at that particular layer of the atmosphere over the ocean. But it's an incredibly deep upper tropospheric frontal structure, 130 knots in the middle, comes all the way down to 800. Let's see if it gets better. Let's get rid of this time and click forward that time. Yeah, one more. One back. Okay, let's go right here. So this is more the Sonoran Desert that I was talking about, with my recollections right. Yeah, perfect. Okay, let's see if that shows us. Whew, boy. Same thing. Look at this. This is stratospheric air down to about 820 or 30 millibars. Extremely intense upper front, wind speeds 120 knots. So I guess that's about the limit on this structure in this forecast. But I did see one of these plumes come down to 900 millibars, and this is not very far off from that. But this is really impressive, this upper front structure. And that's the feature that once it rounded the base, if I had time to prepare, I would have shown you because I looked at it on Wednesday into Thursday. This upper vortex, the vortex feature is mostly a shear vortex feature. And that was enough to produce substantial forcing and actual quasi-strophic vertical motion at the time of the snow in successive model runs. So when the HRRR was saying, we got to worry about, we're not going to get that much precipitation, that was not a function of a decrease in the forcing. It had to be something else because the GFS was showing the same thing all the way through the middle part of the week. So, and it was this feature right here. So a really impressive upper front in this particular case. So that's what I have for the current weather. So, any questions or comments before we go to Patrick?
I'm just interested that sort of like in the plane view, if you go back to the cross-section view, unless you got rid of it, that's okay. I was thinking in the plane view, it just looks like it's a tongue of tropospheric air, but if you follow the whole feature, it's almost like a skirt, right, that like lies along the whole jet feature, the tongue.
Yeah, if you try to imagine a 3D picture here, it's going to be something sticking down through the troposphere that will look fan-like in 3D right here.
And I'm wondering how much of that gets left behind to become like sort of a left behind stable layer.
I'm not sure I know what you mean.
So like the jet flows downstream and moves over us in the coming days. So how much of that sort of 2 PVU extension down to the lower free troposphere is left behind on the west coast?
Oh, well, probably not very much because the circulation changes too as the baroclinicity gets moved around in a different way. Up through this time, won't show it, but you could. I think you can show that this is probably strongly forced by slight or moderate cold advection and cyclonic shear, which forces descent right underneath the jet core. As soon as the baroclinic zone rounds the base of the trough, you very often see a change in that temperature advection, and the consequence is you kind of restuff the tropopause back up to heights where it belongs. So I don't think this stuff actually breaks off, certainly not regularly, but it might in some cases, but I think more there's a tendency for it to recess back to its normal height, and the trough gets kind of weaker and wimpier, and so there's always mixing on the boundaries, of course, but I think you don't really leave big pieces of it probably, and the thermal structure evolves too as a consequence of the way the vertical motions are moderating the temperature structure. It doesn't take much. If you just turn off the slight subsidence here and even make it less subsident, but still subsident, the baroclinicity comes right, disappears almost immediately. And if you put a little ascent under the jet, which is characterized by warm advection and the cyclonic shear, then you just completely reform those isotropes to zonally or flat across the cross section. So
You could probably interrogate that with BIS5E and find out.
you
what
definitely
happens to it
could.
pretty easily.
You definitely could, and you could put trajectories into the middle of these stable zones, right at this height, at this height, at this height, and just see where they go, and then trace what happens to the stratification, which would be really interesting and quite tenable. You're right, it's immediately obvious, not immediately available, I should say, how you can do that. So that's a cool question.
Yeah, it'd be interesting to know if like heating over the land, turbulence in the boundary layer would do more mixing, or like stratocumulus over an oceanic layer.
Yeah, I'm really surprised if the stratocumulus can do any damage to this just because the circulation's so wimpy on top of those things. It's strong for the clouds, because the clouds don't need much perturbation to either erode or get stronger, but you got to do a lot to mix that stratospheric air out. But it's an interesting question, and it is tenable. You're right, Pete. You could actually do some kind of back-of-the-envelope calculation on that with Vis 5e.
Forward
Right off the bat.
contradictory analysis,
Sorry?
maybe some just forward contradictory analysis there, that
Yeah.
would take a couple seconds to.
Yeah, it would. You just identify the right cross-section, and now we know the time, and you could take the same GFS run, and yeah, what I would do is I'd initialize some trajectories, a cluster in there, a cluster in there, and a cluster at the tip, and see where they all come from, and where they go.
Interestingly, this week, I think with this system, there was a bunch of severe turbulence warning areas.
Is that right?
Over the west.
Whoa, that's interesting. Yeah, so this is, that's Mel Shapiro's idea, that what we're talking about, the penetration of this air comes along with really substantial turbulence at the boundaries of that thing. Because there's a lot of horizontal and vertical shear, because it's a funnel zone. And that accounts for probably why, the PV and some of the other characteristics get mixed out in that little narrow tendril that's down there at 850 millibars. But the big chunk of it is a little bit harder to erode by turbulence. This piece here is probably easier to erode by turbulence, but how interesting. And that would be at, as you approach to Phoenix or approach to LA.
Yeah, right.
It's not in the middle troposphere, it's as you're coming down, which is probably the last thing you want. Yeah, really interesting. Flagstaff would be even worse, because you're at elevation too.
Ozone formation too.
Oh, yeah.
Yeah, tropospheric ozone, that's a really interesting case, so.
It would be interesting, isn't it?
Yeah.
And aren't local standards determined by the progression of these kinds of features? So, people down in the LA basin, they get yelled at because their ozone's high, but sometimes it's because of these things. And, Brad, I know Brad is, I think you and Brad are both working on that to try and see how does synoptic meteorology influence the background standards so that we're making the right calls for these various locations, because otherwise it's a free-for-all and you get too rigid and it's not fair. You want to be as fair as you can. I think the peak season for this is March and April in that location. And maybe we should just do that. Just find out if that's true.
Paper.
Yeah, right, just find out if that's true. I think it is true. And one signal is the coldest month of the year in LA at 850 is March. -5 is the average temperature there. And that's colder than any other month. And it makes you think there's constantly a forcing for deepening troughs there. And part of that's bound to be upper fronts. So, anyway, I've said more than I should. Patrick, thanks for taking over. And thanks for the great questions.
All right, thank you. So let's go to the loop of the GFS, yes. And I'm going to focus on two things. First, that precip event that's going to happen Wednesday night to Thursday again. That's the 4th week in a row we've had one of those. And then there's an interesting development that's going to happen over Seattle, Washington, and go into California might cause record low temperatures and snow for regions like Seattle has had 1.8 inches all season. And they might get 2 inches, so that would double their snowfall for this whole season. But it's a weird development that happens. So first, I'm going to talk about our weather event. So let's go to 0 hours of the surface here. Let's see, so this is a look at this morning. And we see this is our low pressure system that brought us our snowfall. If we could actually pull up the loop, Pete, I'm sorry. Yep. And we'll step through these times here.
Looks like so this run only goes up to 21 hours. I'm going to go back to the 6C, if that's all right.
Sure. Perfect. So let this run through and then we can go back to the game. Okay. Let's step forward to 12 hours, 12 ETC. Here. Just get our bearings. So here's the snow event for us. One thing I want to point your attention to that won't be relevant until I talk about it, but this feature is the snowmaker for Seattle. So if you want to watch that, that's fine, but I'll touch on that. This is that shortwave feature that John was talking about associated with an upper level baroclinic zone. If we step forward a few clicks here, this feature on the model runs last night, if you keep going, this feature extended down towards our region. It doesn't look like the current, if you can keep going like 2 more clicks. Current forecast is for this not to really have any effect for our area other than cold air advection to our north beginning. But we do see that we stay dry for, this is Saturday morning, if we could keep going a little bit. Let's go 2 more clicks. We stay dry on Saturday, it should be sunny, we have high pressure, so most of the snow should probably start beginning to melt. If we step forward, you can just keep clicking here. We'll see sort of the same ordeal for Sunday now. We see a low pressure beginning to develop. That's not expected to impact our region. We should stay dry and sunny for Sunday. And you can just keep going to speed. That's perfect. And so we'll see not a lot happens over our region. There are these weak lows that begin to develop. They move mostly to our north. We don't get a lot of precip, which is the shading here. If we keep going, this is going to be our next event, our Wednesday into Thursday event. You see it develops as sort of a Colorado low. If we keep going, we have a baroclinic zone setting up. Now we have a chance for precipitation. This is Wednesday evening. Keep going. And let's see, if we can stop right there. The 540 line is my pointer right here. This is Wednesday evening. It is right over Madison. So that's 4 weekends in a row, or 4 weeks in a row. Thursday, we have the rain snow line right over Madison. Low pressure system developing almost the same exact way each week. We may get snow, we may get all rain. Last night, the 540 line, the rain snow line is well to our north. So this was all rain. This is looking like maybe there's a shift towards more snow. If we could keep clicking here, let's see how this develops. 540 line, let's see, it stays right over us and to our south. So this might be a big snowmaker again for us.
Even believe that happens.
Yeah, which would be, you know, another 4 or 5 inches of snow at this stage. And it continues to snow for a while here until Thursday evening, which is exactly what happened yesterday. So that's kind of remarkable that that happens. And then we get cold air advection like is happening today on the backside, and we get cold again. But, so that's our snow and potentially rainmaker. Now I want to focus on this feature over Seattle. So if we could go back to the start, please, Keith. So go all the way back. Perfect. Okay, so at the beginning of this run, we have a big anticyclone sitting over the northeastern Pacific. There's a cyclone that moved off of Siberia, and then a little wake low that formed in the cold air. And this feature, this wake low combined with the cyclone, is going to be part of what brings record cold temperatures into the West Coast. So if we could step forward just like we were doing here. We see this cyclone sitting over Alaska. Here's our polar low that forms in the very cold air. Keep going. We see, here's the cold air from Russia. It gets slammed up into the mountains in Canada and Alaska. It sits there. We have an anticyclone, a baroclinic zone cutting right in between it, another anticyclone, and we have a low developing, which sounds familiar based on my research.
Sure does.
This low moves in between these two anticyclones. We have that cold air sitting still up south of Alaska. And as this low pressure system continues to move, we see it drag down all of that cold air. And if we could keep going, we see all these lower thicknesses getting dragged down, right down the coast. And this 540 line, this is the line I'm highlighting right here, gets all the way down to the southern tip of California. So presumably all of this precipitation is snow. Now that probably won't happen just because you have a warm ocean, but there's a chance if we could step back a couple clicks. Just keep going. Perfect, right here. We have a period of like 2 days where Seattle, Oregon, Northern California could see snow. And this is very uncommon for this time of year. I looked up the typical temperatures for Seattle. They're about 50 degrees is their high and 35 is their low. So having a snow event, number one, is anomalous for this time of year, and then two, having temperatures this cold, which I'll highlight in the 850 maps, is also anomalous for this region. And these cold temperatures get all the way down to the southern tip of California. So this is an interesting feature that I highlighted when I was going through these surface maps.
528 is usually the line people use in Seattle for rain and snow. And it's probably true along the whole coast, but that still puts them firmly in the risk of snow.
Right, let's see, if you could, Pete, go forward, once this line gets all the way down, let's see, okay. Let's see, what line is this?
The next solid one.
Next solid one's 510, yeah.
Okay, so it's pretty close to that thickness,
Yeah,
I would
that's
say.
definitely a snow event for Seattle, and
Yeah.
it is unusual at this time of year. When it happens, it tends to be associated with a persistent cold in its wake.
Right.
So these things are not momentary the way they are here. It's very much a part of a larger scale circulation anomaly that stays for a while. And in fact,
Right.
Matt Hitchman's hometown of Bellingham is right on the north coast of, the northern border of Washington with British Columbia, and this kind of setup brings extraordinarily gusty winds down the Fraser River Valley, right into Bellingham. He's not here, it's too bad, he talked about it, probably got lots of memories of that.
I can believe that based on this pressure gradient that sits and just drags all the cold air straight south.
Yeah, and the one along the coast is even more compelling.
Yeah.
The coast of British Columbia, I mean.
Oh.
Because it's dammed up by the mountains.
That's right.
So it comes right through any gap, and the Fraser River Valley is one of them.
That's right.
Really strong gap flow.
So let's look at the same view of this at 500, the same loop we just beat. We can see why did this cyclone form initially? Let's see, let's step forward to, I think it was hour, I don't know, 90 maybe? We're looking at Tuesday and Wednesday, so, okay, let's stop. So first we have a slight short wave in the flow, if you can believe that. This will become more prominent as it moves toward the coast, but it's associated with a strip of vorticity that's connected to another geopotential minimum south of Alaska here. So if we could keep stepping forward, we'll see this evolution. This becomes more of a pronounced wave. Let's see. More of a pronounced wave in the vorticity, not really in the curvature, but there is definitely some forcing for ascent ahead of this. And I was trying to diagnose this using PVA by the thermal wind. There wasn't a clear, the thermal wind is located and blows parallel to these strips of vorticity. So to my eye, it seems, if we could go back a little bit. Thank you. There's just a slight trough that appears, and that might be just enough to form a low that just sits over Seattle and doesn't really have any tendency to move. If we could keep going forward here. So this feature moves over the mountain west, which is what we were looking at earlier today, and keep going here. Develops almost the exact same way as the feature that John was talking about. And there we get our another snowmaker on Wednesday night into Thursday.
But the same kind of one too, because the
Yeah.
confluence just north of the Arrowhead of Minnesota is just going to shred any sort of
That's
tendency
right.
for a ridge to build. So it's going to be another one of these linear type features, and short-lived. Maybe if you're in the right spot, you get a burst, but no prolonged, 18 to 24-hour snowfall.
Yep, that's right. Almost the exact same thing, which
Which is
is
very similar.
very weird. And then if we could do the same loop for 850 drops. And this is the most compelling way to look at that cold air that's brought down, in my opinion. So let's go to hour 90 again. We'll step through. So we had that low pressure. It's dragging all of this air. This is Siberian air. And we see, so now we're at hour 90, if we keep stepping here. This is a straight shot of air all the way from Alaska, straight down through Seattle, through Oregon, down to the tip of California. And this air just sits there, as John pointed out, because you don't have any real forcing. You have a big mountain range sitting there, so all this air is just trapped. Right along the coast, you got big snowfall. If you have any forcing for ascent, in which we did, we saw a low pressure sitting over the Seattle area and just slowly moving south.
Yeah, and it doesn't hurt to have a big cyclone to the northwest of the North Slope of Alaska. That kind of kicks a ridge up
That's right.
over western Canada, which reinforces the northerly flow at upper levels. And so the cold air just keeps draining.
That's right.
Really interesting.
So then if we could go, one last site I have, we could go to weather.gov. Found a cool site that we can track just how anomalous this air will be. And if you scroll down to the very bottom to past weather, right there, and then we'll click on Seattle. So this will pull up climatology, almanac data for any ASOS station that's listed here. So we'll do Seattle City area, and we will do daily, monthly normals, and we'll do daily. And I think it's temperature and preset. Yeah, we'll do temperature and preset. If we click go, very quick way of plotting. This is the one. Let's go back, actually. There's a more, must have missed that. Maybe climatology for a day, maybe that's what it was. Ah, here we go, okay. Wait. Daily data for a month, let's check out. Okay. No, there was a monthly. What is this daily, monthly, normals one? That's what we have. Anyway, we can do climatology for a day. Let's try that. And we'll do, we'll do the 23rd of February for Seattle. Click go. I'm not sure why I couldn't find that other plot, but, so this is a look at February 23rd from the past 20 years or so in Seattle. You can see in the 50s, their usual high is about 55. I'm sorry, I can't find that graph. And typical low, maybe around 35. And so if you get a persistent cold outbreak like this that's going to produce snowfall, these minimum temperatures that are observed are going to become your high temperatures. And I was looking at Thursday, February 23rd, and then Friday, February 24th. The minimum temperature in Seattle for both of those days were in the mid-20s. So if you can get this Arctic outbreak going, you get snowfall, radiational cooling. After the snow falls, we could be talking about record low temperatures for Seattle. And this is just Seattle. This is going to be a regional event over the entire West. And if we could pull up one more plot, we'll go back to the weather.gov. Just pull up one more plot. And we will go to...
Yeah, they're talking about a big Kona flood in Hawaii right now, based on what we've seen on the satellite. That's interesting, too.
Let's see. We will do weather. And if we could go to day, let's see, let's go to day 5. So you can see this is all that snowfall that's predicted because of the cold outbreak. And then I also know that from the climatology, there is a very likely chance that we will have below average temperatures, and it's along the line from basically western Montana straight south, and just the west coast is in that bullseye. So are there any questions about what I had?
Very cool. Can we go back a click and see what they're saying about Hawaii? That was
Yeah.
That was on the banner or the Weather Service page. Or right at the top of this page, I think. Yeah, what's this about Hawaii? Oh, can't read this text.
I know they have, if we go back actually, and scroll down to the Hawaii map, there's flood warnings for all of the islands.
Oh, yeah, okay, there you go. That's really interesting. Yeah.
Snowfall for...
They already got a flood in January, so they got another one coming.
That's right.
It's kind of like Auckland has just been hammered this winter, their summer. Just horrible, one after another. Man. Dangers of living in the subtropics.
Yeah. Well, perfect. Thank you, everybody, for coming. Thank you, Pete, for driving.
Thanks, Patrick. Thanks, Pete.
Yep.
All right, we'll see you next week.